Many Australian soils have chemical and physical constraints deep below the surface, which restrict the growth of plant roots and limit crop productivity. By applying manure or plant residues into the subsoil, some constraints can be overcome or minimised in some situations. This process is called subsoil amelioration. Research showed that yields improved by an average 10 to 15% in Southeast Australia, thanks to subsoil amelioration. But they range anywhere from no response up to a 65% improvement in crop yields. What's more, the improvements in the soil can last at least 5 years. Subsoil amelioration is very expensive and can cost up to $2,000 per hectare. Yield responses heavily depend on the rainfall and soil properties. That's why Agriculture Victoria has developed a decision support guide to help grain growers in the medium and high rainfall zones decide when they're more likely to reap the rewards from subsoil amelioration. Amelioration may be worthwhile on consistently poor performing soils with at least 400 mm annual average rainfall and where the soil constraint is less than 35 cm deep. Subsoil amelioration is unlikely to be worthwhile on vertisol soils. These are often known as cracking clays. It also does not work when the following season is very dry, and the benefits are not evident when the following season is very wet. Amendments used in amelioration include animal manure, plant material, or inorganic materials. Ideally, about 10 to 20 tonnes of organic matter per hectare are placed where the soil constraints start to limit root growth. Plant-based organic matter is usually easier to access on farm and in large quantities than animal manure. It's also less likely to cause yield losses in dry seasons. In recent research, grain yields increased significantly when cereal straw was treated with nutrients to help it decompose. Amelioration can be achieved by deep ripping or mixing soil. Special deep tillage machines are usually used to place the amendment into the subsoil. This is often achieved using a wingless deep ripper shank with a narrow chisel tip attached. A large boot guides the organic matter using gravity, immediately behind the shank. This operation leaves a sausage of organic matter in the top of the subsoil constraint. Amelioration is easier in sandy topsoils, but problems can arise if the clay subsoils are too wet or too dry. Subsoil amelioration improves water and air movement through the soil, which helps root growth and nutrient and water uptake. It effectively increases the size of the soil water bucket available to crops. It also leads to less waterlogging, better soil structure, more rainfall infiltration, and more nutrients available to crops. Consistently poor-performing soils with good fertiliser and disease management should be investigated for subsoil problems. These areas can be picked up in yield and NDVI maps. If a crop's performance is well below the water-limited yield potential, it's clearly not using deep soil moisture. You need to do your sums before considering subsoil amelioration. The costs need to be balanced against the size of the yield gap. It can take 3 years to pay back the initial investment in soils. To help decide upon subsoil amelioration in Victoria, see Agriculture Victoria's website.